These are the notes for Module K, Unit 2, Lesson 2. The topic is measurement and the metric system. Today in class, we took a quiz. After the quiz, I had students watch the metric system video in Edpuzzle. You can find that link on Schoology. And there are definitions for the vocab words in this lesson. There are 3 learning targets in this lesson. The first is I can use the SI system of measurement. Second is I can use scientific notation. That's one that some of you are familiar with from math. And lastly, I understand the difference between accuracy and precision. Those are 2 words that you maybe are familiar with, but have used them differently in other conversations than we will in this lesson. The vocab words in the lesson are measurement, which is a determination of the dimensions of something using a standard unit. So basically, it's a description using a number and a label. Scientific notation is a method of expressing a quantity as a number multiplied by 10 to the appropriate power. We use scientific notation for very large and very small numbers. Accuracy is a description of how close a measurement is to the true value of the quantity measured, so how close you are to the correct answer. And precision is the exactness of a measurement. Is it repeatable? When you measure that thing, can you get the same measurement over and over? The SI system stands for a French term, System International or International System. It's the standard units of measurement that are used worldwide, and it's also known as the metric system. The SI system came about in the 1700s when the French National Assembly agreed that having people use all of these varied systems of measurement and having measurements with different values, for example, the foot was the size of the king's foot at the time, and they kept having to change it. It wasn't efficient, it wasn't good for sharing or comparing information. There were actually a lot of arguments when people disagreed over the value of a measurement, and so they agreed upon the SI system. The United States is one of 2 countries in the world that doesn't use it, but even in science labs here, we do use the metric system. So we're going to look at some values of measurements in the metric system, or base units. The unit of length is the meter. That's measured, the symbol is a lowercase m. Uppercase and lowercase letters are important. Make sure that you follow what you see on the screen here. The unit of mass is the kilogram. That's abbreviated kg. Time is measured in seconds, abbreviated with an S. Temperature is measured in kelvins. That's an uppercase K. Notice that it's not degrees Kelvin, and that's named after the man that came up with that temperature scale. Science is really the only place that you will see temperature measured in kelvins. Otherwise, you'll see Fahrenheit or Celsius. Volume is measured in liters, uppercase L. Weight is in newtons, uppercase N. And density is in grams per milliliter, G/ml. We can take any of those base units and insert them in the middle of this next table. And then we add prefixes as appropriate for the size of the measurement we're working with. So the prefix kilo is a factor of 1,000. Hecto is a factor of 100. So a hectometer would be 100 meters. A kilometer would be 1,000 meters. Deca means 10. A decameter would be 10 meters. Then the base unit, like meter, gram, or liter, goes here in the middle. For smaller values, deci, D-E-C-I, is 1/10. And you see it written here as both a decimal point and a fraction. Centi is 1/100th. Milli is 1/1000th. And then a micrometer or a microliter would be 1/1,000,000th. And that's an italicized M. So to convert, you multiply or divide by 10. And then we looked at scientific notation, which is a way of writing very big and very small numbers using powers of 10. This is something you'll have to add to your notes. It's not typed in the skeleton notes. So in standard notation, we might have a large number like 59 million miles. It has a lot of zeros. In scientific notation, we would write that number as 5.9 times 10 to the 7th miles. To get that superscript, that little 7 on your computer, highlight the 7 and then hit Control, period, and that will make it a superscript. To change back to regular font, do Control, period again. And here are 2 hints to add to your notes. Move the decimal to the left for big numbers, and you end up with a positive exponent, like we had up here. Or move the decimal to the right for small numbers, and you'll end up with a negative exponent. So let's practice. This first number is 0.00067 meters. You would write as 6.7 times 10 to the negative fifth meters. So I start with my decimal point here, and then I count 1, 2, 3, 4 places. Sorry, that should be 10 to the negative fourth meters. And it's a negative exponent because it had a very small number. Then here, 137 million centimeters would be 1.37 times 10 to the 8th centimeters. This number we would change to 5.2 times 10 to the negative 9 grams. Again, it's a negative exponent because I started with a very small number, where this one's a positive exponent because I started with a big number. And then here, 4.67 times 10 to the negative fifth liters. Lastly, accuracy and precision. The bullseye is a really helpful visual to understand the difference between these two. If the bullseye, the center of the target, is the correct answer, accuracy is how close your measurement is to the bullseye, how close you are to the correct answer, the true value of that number, that measurement. Precision is how close your answers are to each other. Can you get the same answer, the same measurement over and over, like these X's here? And those are the notes for lesson 2.